Hey everyone, welcome to Your Desk University. Another great session. Are you trying to keep your teams focusing on design and less on placing furniture and how they name their view names and sheets? Well, you really should be. Because if all of the tech industry and innovators are focusing on handling these little problems, we really have a broken system. And I imagine some of you are agreeing and cheering with me right now. Let's see today how one tech innovator is doing that for his team. I'll introduce him in a moment, but I'm grateful to see you guys all here and definitely say hi in the chat. What can you do to help us? You can definitely hit the like button and you can share about this on social media. This is a completely free program. We try to bring you our tech innovators some of the best content and quality, and sharing about it is one of the ways that you can help us grow as we keep doing this. But we've done now, I should count it, but 32 of these. And I'm grateful for your support in the ways that we've been able to accomplish this. Let me see here. Sorry about that. Definitely check out our other videos. We had a great session last week with Havard Vashaug. Also, if you're finding us on YouTube, go ahead and go to yourdeskuniversity.com or click on that Our Full Schedule if you want to see other things that are coming up. I'm grateful for having Chris Mackey joining us, and we're just about to post that, but we're always having changes to our schedule. So that's the best place to get the latest. So yeah. And with that, I want to welcome our speaker. This is Oliver Green, as I mentioned. I first met him on, I guess it was on the Slack channel on Revit, which he was introduced by Rado Gade to there. He's been studying machine learning and trying to really help his team at AHMM do better. He comes to us from London. Is that right?
That's correct.
And we've definitely been able to expand much more towards Europe this semester, and we're grateful for that. So with that, Oliver, tell us a little bit about how you're helping your teams focus on design.
Thanks for having me. Welcome one and all to my lovely floor. And because we are in Europe, this is the evening, so it's 9 o'clock over here. So forgive me if I sort of appear to be nodding off, but I'll sort of try and power through. Helping the teams focus. So I work at AHMM. We're a very large architecture firm. We're about 500 people. We have a tiny Oklahoma City office and a few others scattered around the place, but mostly London Centre. We're about 400 architects, 100 support staff. And I originally sort of interviewed there as an architect. I am an architect by training, and then took on this sort of role that we'll kind of get into. And I joined the digital design group, initially having kind of played around a bit with Dynamo, a bit with Python. And I kind of
Looks like we're having a little bit of audio
this job
issues coming in. You're back, but we lost you there for a second while we were figuring out audio.
Oh no!
Hopefully,
how much of that did you get?
I think we got a little bit about how you got started as an architect, and then I think we lost the rest.
Okay, so I joined AHMM. Originally interviewed as an architect, and through the interview process, just kind of switched it around and started pitching this new role to them. And one of the directors, there's 4 directors, AHMM, said to me something that's you can not spend their time fighting against data, against software, against sort of technology and all this kind of stuff, which is kind of to encompass our role so very deeply. So that has been my mission from day one, and 4 years on, I'm still here at AHMM. I love this mission. I think it makes a ton of sense to me, and I'm very glad, sort of having trained up in both architecture and sort of software development, I'm now in this position to sort of try and build bridges between different pieces of software, smooth workflows, and generally sort of try and lighten a load on architects' shoulders.
So really, you're like a lot of the people who are watching this, who are like, this is a broken system. We together need to come around it and help solve it. And you're a designer first, which I think is true about a lot of us as well. So that's really cool. So I saw recently
Yeah,
you've been
and
working.
I found there was quite a few parallels, really. Go on.
Yeah. Yeah, we're getting a little bit of choppiness. No worries. We'll just try to, figure it out as we go. I've heard most of it, but just obviously it seems to be a delay between DC, London, back, YouTube, the rest of the world. So everyone watching us, you know, this is what we get these days. Um, so tell us a little bit about. Can you show us a little bit about Homegrown for those who haven't seen it? And then I'd like to get a little bit into the weeds of how you came about it and some of the pieces. And hopefully this works. I hate to say this, but I might ask you to turn your video off at some point. But let's try it with your video on first for a couple more seconds.
Okay, sure. How about I start by demonstrating it? So, I mean, I think there is a GIF that people are fairly aware of that they've sort of seen on places sort of Twitter, LinkedIn, this kind of thing. This isn't sort of these aren't the only shapes that sort of it works with, I promise. But this is sort of my very basic testing file that I use because it's so kind of quick and easy to demonstrate the technique. To sort of try and understand how can we improve our process behind residential design. We do a lot of apartments. I, as an architect, worked in a lot of London-based apartments, and they're not entirely unique. They're not entirely different either. There's a lot of similarity between, especially one-bed apartments, two-bed apartments, and I wanted to look at this and say, how do I create something in the middle that isn't always completely unique and completely high architecture, but isn't completely systematized and sort of just modular box-based stuff you assemble on site, which is often where the apartment design challenge falls. I also did a lot of research into kind of things like generative sort of design approaches, algorithms that would read space. There was plenty of stuff coming out. There was a deep learning paper that was very influential. And I also kind of didn't want to go down that route. So I wasn't going for the high art of architecture. I wasn't going entirely sort of systems engineering, and I wasn't going entirely algorithmic generative design. I wanted to find something somewhere in the middle that was sort of try and get the best of both. So my attempt was really to work from the back forwards. So take the solutions that our architects have already designed. We've designed hundreds and hundreds of apartments. Why can't we just say, hey, we're going to have something similar? If we look at an empty space, we're likely to have, an L-shaped corner apartment. We're likely to sort of have a mid-slab apartment that's sort of single aspect. We've probably designed things that are reasonably good, or at least, they'll do 90% of the work for you. So what Homegrown is it's a very kind of quick and easy tool that sort of we've developed internally, and it's a two-click tool, effectively. One clicks in the space, and then one clicks to place an entrance door, the rough location of an entrance door. So I can click once in this kind of corner apartment. I can say this is roughly where I want my entrance door to go, and it looks through our database of all the designs that sort of we've come up with in the past, and it sort of ranks them. This is very important. So I've kind of got the ability using these tabs at the top to kind of filter them down by the number of beds or the year they were designed, that kind of thing. But it ranks them. And I think that's the most important thing about Homegrown is it's basically able to sort of look at a space and say, look, what have you designed in the past that's similar? And rank them according to similarity. And I'm going to go into the algorithm a little bit more, but it gives them the ability to then sort of basically review designs that might suit the space very well. You double click, you pick one, and it basically applies and sort of stretches, and it doesn't change the dimensions of anything. In fact, I can sort of show this better.
So we're getting a little audio glitch there. It's been pretty good, which is awesome. I'm keeping an eye on this. John's going to give me feedback
sort of
if we
does
need
best
to cut it off.
So,
but one of the things I kind of wanted to say as we're figuring out this audio thing is when we were talking about it, we were talking about behind the scenes about how the placement can happen.
Well, I turn off my video.
Let's try that for a second and see if that's any better. I have a beautiful Teams logo. But so Oliver, I was just kind of like thinking about how when we talked about it, you were saying like, hey, we're not like designing the whole thing, but you're looking at like UV placement on the room of objects and then comparing it to past designs, right? I kind of want to get into the weeds a little bit if we can.
Sure, let's go into the weeds. So I've published this paper. This paper is available publicly. So the introspective approach to apartment design. So that just means really looking inside for the answer. So can we look within what we already have, the apartment designs we already have, to kind of come up with an answer for the question you posed, which is the space that you have. So initially, what I started doing was I collected together apartments. So I think I got something like 87, 89 different apartments, and I collected them together in Revit in one big file, and I standardized them, all the walls, all the beds, all the windows, all this kind of stuff, so that sort of we were dealing with sort of a common baseline for our apartment data. I took which I can sort of point diagrams. Sort of, this is going remarkably slowly, I have to say. Can you still hear me?
I can hear you, but it's definitely choppy. This is what we get for doing live. I think considering the fact that we've had 32 of these and not very many with choppy audio, I think it's totally okay. But let's keep trying just as we go. I'm going to turn my video off on Teams, which won't impact the viewers, but that might help. And then, yeah, I mean, I'm thinking it's on your end because I'm getting a pretty high band rate here, but it is what it is. No problem.
Sorry, the dodgy London infrastructure.
It's life, right?
Okay. So if you can see the paper, these are some of the key diagrams that I think explain what we're doing most importantly. So we wanted to have the ability to, this is sort of my first idea really, was to sort of try and lay down a regular grid on a space consistently, regardless of that space's rotation, regardless of its sort of size or shape. So this was sort of like my kind of success image, really, this sort of purple grid. That was how I knew it was working kind of the way I needed it to. And the way I had to do that originally was to establish a kind of a geometric baseline. So here's an example of a size and shape of an apartment that looks reasonably realistic. It's a corner apartment, whether it's internal or external. And I think rotating calipers is sort of a very kind of a common approach. Minimum bounding box is a very common approach for laying a grid upon a space, or at least sort of laying a kind of a box on a shape in a way that makes sense. However, I found it to be counterintuitive sometimes. And I wanted to have something that I could calculate really, really quickly. There's also a relationship between sort of the geometry of a shape and the way you tend to chop up the spaces internally. So even if you've got something like a circular tower, very often the side of an apartment facing the core is a bit more rational. You might have a curved outside edge, but actually the way you break up the inside spaces of the apartment still tends to be quite perpendicular and quite rational. So I think what I came up with was kind of my own approach, and I don't know if it's original or not, but I called it sort of the dominant vector or the most popular vector, which looks at the edges of the space and it groups them according to sort of their angle, if you like. Not necessarily the vector, because you can have some of these, could be going in opposite directions. They'll still be grouped together. But if you look what we've got kind of our red lines, our blue lines, and our orange lines in this diagram. And if you kind of add up all their total lengths, you think, well, the red lines are probably the dominant vector in this case. So that is what it allows us to establish a box. And from that box, we sort of then take an anchor point, which I think is the lowest leftist point, and say that is the start of our UV grid. The UV grid, I've just got some examples here in purple of how that gets chopped up. And you kind of want to pick a number that's sort of not too many squares and not too few. So I just picked a kind of 10 by 10, partly because it felt right. And partly because I thought that would give us enough resolution, but not too much that it would take ages to calculate. There's sort of a diminishing returns as you increase that number. And then I had to have a think about, I wanted the ability to match apartments regardless of how they were rotated and regardless of how they were sort of flipped or handed or sort of switched around. So because I have to choose an anchor point for my UV grid, I'm therefore introducing a bit of bias. And I wanted to have the ability to sort of recognize this L-shaped apartment regardless of how it comes. So this diagram I've got on the right here shows that I had to basically take 8 imprints per apartment. There's initial V flipped, U flipped, U and V flipped, and then there's sort of the same, but with the axes switched around. And this is just a bit of maths, really.
And so is that true for like every shape that you create? You create these 8 variations of every kind of like base room shape?
Yes. So if I had 100 apartments in the library, I would actually have 800 apartments that I'm running the comparison on. The benefit is you don't necessarily kind of have to know which one is right. When you do the numeric comparison of things like the geometry and the entrance vectors and everything, the apartment that is the most suited apartment jumps forward because it's the highest rated and all the rest aren't particularly highly rated. And then finally, I think it's important to know is that the UV grid is measured sort of between 0 and 1 in both axes. That gives us the ability to point to any location within our grid, which should encompass the entire space. And then effectively you have two floating point numbers that could be a reference. So you could have 0, 0 is your grid's origin, 1, 1 is the far corner, 0.5, 0.5 is the center point of the grid. And this gets applied regardless of the shape. I think it's actually pretty robust. So you can have, you can have something like a curved apartment. It's not really a big deal.
So every shape in the apartment gets placed on this UV grid as just a point right now. You might have, do you have line-based elements as well that own kind of two UV coordinates?
That's exactly right. So if you're familiar with the Revit API, you can place basically everything with lines and with points. We're not doing any sort of, complex adaptive component geometry or anything. This is good old-fashioned lines and points, which give you the ability to relate everything in space. You can also do things like measure how close together the doors are. So, when you do those two clicks in the start and you click to place the door, well, that gives you a kind of a UV coordinate. Then you can, in one of the ways you rank the two apartments, you can say how close are their sort of entrance door UV coordinates, for instance. And that's just simply a floating point, one number minus the other number. So the U minus the U and the V minus the V, and that gives you an idea of how kind of similar or how different they are. In terms of sort of comparing the shapes, I was inspired by a very old approach for recognizing handwriting, sort of handwritten letters or digits using machine learning. And initially I was thinking, what, have I got to have a library of L-shaped apartments, a library of kind of boxy, long apartments, these kind of things. And then I realized I don't need that at all. I can simply compare the two shapes in terms of their matrices of numbers. So what does that mean? I've got my 10 by 10 grid. And within each 10 by 10 grid, I actually put another 10 by 10 grid of dots. So within each square. So you wind up with 10,000 points using Revit API 10. I think it's an XYZ. Anyway, you then test each of those points and say, do you fall within the space we're looking at? So do you fall within what I've labeled here, the candidate area? And if you do, then add. And if you don't, then don't add. And that, if you sort of top them up, those 100 points per square, you then get a number between 0 and 1 that tells you how much inside or outside our sort of target area that you are. So it's a matrix of numbers really from 0 and 1, so 0, 0, 0, 0, 1, 1, 1, 1, etc. And that's how we save the shape of an apartment. And then if you get another apartment and you want to say how similar are these two shapes, you simply take one matrix and take the difference between that and the other matrix. You subtract them effectively. And because this is all just numbers, it's incredibly quick. It's milliseconds. It's absolutely rapid. So one of the things about Homegrown was a question how to do analysis as rapidly as possible on space, because you can do some very brute force approaches, but if you sort of work in the language of the computer, you can perhaps make things work a lot faster than you would have thought. And so all the analysis in total is done in a few seconds, but the actual shape analysis is in milliseconds. It's absolutely rapid. So that was something that that was very important to sort of try and get right.
And this is just finally, like a nested list of lists or a matrix of zeros and ones, or I guess, is it like a gradient from 0 to 1 for each number as you go around, which that's really fast to work with, right? Compared to like trying to figure out the geometry on every single one of these.
Exactly, you're right. And there is a Revit API process, I think it's point project, that lets you figure out whether a point lies on a surface basically instantly, which is just mathematical. It's looking at coordinates and saying, does it fall within X and Y, these kind of things. The final challenge was a statistical challenge. And that was simply, I take 11 measurements when comparing apartments. So one of them is sort of the shape, one of them is the UV length, one of them is the area, these kind of things. But some of them aren't very easy to quantify and be like 0 is complete difference, 1 is complete similarity. Some of them are. So with our nested list of points, it's very easy to rapidly come at a number and say, look, similarity is 0.499. When I wanted to compare areas, I actually had to do a bit of statistics and look at things like, the mean of a two-bed apartment and the standard deviation and sort of see where those two values fell within sort of a normal distribution. So this might be getting a bit too geeky, but this was one of the trickier questions as I had to face, and I had to put on my statistics hat to really sort of try and solve it.
What do you guys think? Do you think this is too geeky for this audience? I personally don't think so.
Okay.
But no, I think that's what we want. We want the meat and potatoes, you know? I think one of the beautiful things in you sharing this and talking about it is everyone says like, oh yeah, I'm machine learning this, I'm machine learning that, I'm doing this, I'm doing that. But no one steps back and says, oh, I'm actually looking at like this geometry and I'm just saying like, oh, is it solid? Is it not? And then I'm running a statistical analysis on which one of these sets of zeros and ones is the closest, which is really what I think you've just walked us through, which in essence is like machine learning is statistics. It's a great buzzword, but that's kind of what you're doing here, right?
Yeah, you really can't do machine learning without a bit of stats and a bit of maths.
Regression.
And I think the more comfortable you are with that, you know, the happier you'll be. So the machine learning aspect of this, there are definitely machine learning techniques in what I've sort of spoken about already. In fact, since we're being geeky, I can say I have my 11 similarity measurements, and then from them I create an overall similarity measurement using Manhattan distance. And I initially weighted all of the features that I'm comparing, these 11 features, as being equally weighted. They all had a weighting of 1. So they were all equally important when comparing apartments. But actually, we know that's not the case. We know some things matter more than others. For instance, shape really matters a lot more than, you know, necessarily the entrance angle. So we wanted to sort of figure out how can we use a sort of a pure machine learning mathematical geeky approach to sort of figure out the weightings, because I could sit there and I could dial, you know, the levers up for certain features and dial them down for certain features. But I felt like that would be a bit of a cheat. I want to use a machine learning approach. So in the end, what I had to do is I had to use a regression technique. I used 2 regression techniques. Simply, you know, you can use one, you can use the other. I used 2 just to sort of try and cross-check my result. And what I did is I got 13 trained architects to recreate 160 apartments using Homegrown with all of the flat 1.0 weightings. And then I wanted them to rate them. So I got them to do this, and I got them to use this kind of slidey feedback UI that I created in WPF.
So wait, I'm sorry. I just want to go through and make sure I got this. So you started with these apartments that you created, and you told them, "Oh yeah, let's create these apartments," and then I want you, the designer, to go in and look at the designs that Homegrown gave you and rate those. Is that what you're saying?
Nearly. So
okay.
I took a bunch of existing apartment outlines and I used a bit of code to mess them up a bit and jiggle them and change them and everything. Mm-hmm. So I had sort of a kind of a semi-randomized set of apartment-like empty spaces. I then told the architect, look, here's Homegrown, use it, create the apartments in it that, you know, just pick any one you like, really. Pick any design that fits the apartment or doesn't fit the apartment you like. And once it's created there in the space and all the furniture's been placed and all the walls have been placed, they get this pop-up UI. Oh no, lost connection to the remote PC. I hope that's coming back.
I can hear you. You're quite choppy, but I think
you still hear me?
We're still going. Let's yeah.
No?
We might have to. I know Oliver. We've chatted before. I know we can re-record this, so we might have to just do that. I think we'll finish it out for those who are with us and watching this. You know, I love you guys. Thank you. But I think for your benefit, your audience, I think Oliver, we'll just do another one of these ourselves. Try to record it when your internet's really good, and we'll post that as well. So let's keep going, but just so that we know that we'll get something we can watch with a little less choppiness. So.
Yes, I think that makes sense. Maybe it's an evening thing as well. I think right now this is Netflix o'clock in the UK, so perhaps we can park it a little bit sort of earlier in the day and maybe get people while they're all busy at work. Okay, hopefully my screens can still be seen.
Yep, we're seeing it.
Okay, perfectly. So I presented architects with this UI, and this is a slider-based UI, and I wanted them to rate the apartments. So internally, already, Homegrown knows if they recreated a 50% match, an 80% match, 100% match, that kind of thing. But that's according to the flat weighted algorithms. And it kind of knows on each of the features, like feature one is a 90% match, feature two is a 30% match, etc. So it kind of knows all that. What we needed is human input from architects to say kind of, well, how good a job did it actually do? So I had this kind of UI that I designed, and I designed it intentionally using sliders. These sliders are because I wanted basically architects to rate them according to sort of, architects don't work using numbers necessarily. It's more of a sort of a trained intuition. It's a trained gut feeling is the way that we work. You know, if you were to say to an architect, how do you decide what is the right thing for a space? It's not necessarily the easiest thing to put into words. It's sort of it's semi-intuitive. So I wanted them to stay in that headspace and use the sliders to say, hey, it's done kind of well in this, but it's not done that well in that respect. I didn't want them to think numerically. And there's a few reasons for this. One of them is that when you get people to rate things using stars or numbers out of 10, you get some very weird phenomena that occur that 3.5 out of 5 stars is an average, or 7 out of 10 is an average rating. That doesn't make any sense, but people don't really like to rate things that low necessarily. So this is my way to get them to design, to report success back to me in perhaps a more honest way, in a more intuitive way, that they're not thinking numerically. Then you've got the score for every recreation. You can use regression then, and you can say, look, when you've done well, these are the features that shone through. And when you've done not so well, these are the features that perhaps are kind of a bit too important. And you can reverse engineer the feature weightings from these using regression techniques. So I used random forest regression. I used gradient boosting regression, which was recommended to me by Theodore Galanos. And then I was able to reverse engineer the weightings. And you could see what I thought was very, very interesting is the same features were kind of like really, really shining through. Intriguingly, I think I might have got the labels wrong on this, because feature 11
feature
is top
7
here. That's interesting. I might have got the labels wrong when I put these together. But you know what? We obfuscated the features anyway. So the idea is that in blue we have the random forest regression weighting, and red we have the gradient boosting. And as you can see, they align very closely. They did converge pretty closely. So what was also useful is those features really did correlate very well with what we thought as architects would be the most important thing. So I think feature 11 or 6, one of the highest ones, was the shape correlation. How well does the shape match the target space? And then if you can see these two graphs on my screen.
I'm currently, I think maybe stop sharing and start sharing again. I'm seeing the graph at the top and the feature list at the bottom.
Yeah, let's try this again. There should be these two there we go, two colorful line graphs. And on the bottom here, we have as I increase the number of apartments in the training data, we can see that kind of the lines begin to converge, and red and blue shoot up to being the most important with both regression techniques, and then the others sort of settle amongst themselves. But the feature weights definitely correlated with what we thought were the right weightings given a sort of professional experience. So I'm pretty happy that we think it's worked out, and that means now that it should be able to recommend apartments given all the data as an architect might, at least in theory.
So you found that really of all the features you were trying to look at and comparing, there was two that shone above the others for people's preferences.
Absolutely, and they make a lot of sense. I think they're the most they're the strongest kind of guiding features when you're sort of comparing apartments. So things like,
and I can respect this kind of anonymity with regards to also sharing your guts. I mean, you're sharing a lot about how this works and what's behind Homegrown. So I appreciate that you're also, respecting your own, what you consider maybe your secret sauce.
Yes, 100%. So I developed this for AHMM. They kind of pay my salary at the end of the day, and it was a question of sort of how much do we give away? We don't give away everything. We don't publish the code necessarily, but the approach behind the algorithms, I kind of wanted to communicate a lot, because in the end of the day, it got a ton of attention on places like Twitter and LinkedIn and stuff, and I was really happy for that. And I wanted to give people enough that they kind of wouldn't be hungry for more and be like, oh, we just wish that he told us how it worked. And I think now there are probably a bunch of really excellent software development companies out there in AEC who would be able to recreate something equally as good or better than Homegrown, especially having kind of published this paper. But it's a fine line. Where do you call it?
Let's try for a moment sharing your screen, sharing your video and turning off the screen share again, and maybe have a little bit of conversation. I think this is becoming very informal. I'd love for us to talk a little bit more and kind of give room to the audience if they have questions, and maybe we can get your face back. Right now I have a picture of you that I posted with you looking very dapper. I don't know if that's hopefully that's a good term in the UK as much as I am intending it here in the United States. So
you called me what?
No. Exactly. All right, so, but I need to hide your I need to hide the picture. So with that, and looking at the chat here, I'm just gonna say, why don't we take 10 minutes or so, and if there's any questions, we can take as long as the questions come in. But just talk a little bit about this again. I think for the more formal thing, we'll probably re-record a little bit some of this and post it, because I do want to share what you're doing, and I think it's really interesting. And for me, what you are willing to share with us is kind of what Your Desk University wants to be doing, and that's kind of elevating the industry as a whole by taking some of the stepping stools that people are open to sharing outside. So you're, interested in sharing a little bit about, the UV grid and how we set that up, how you personified and kind of got the emotional aspect of the design into your technology. And I think those were really interesting pieces. And I also appreciate, and I think for people watching, it's really important for us to respect our companies and what, the potential IP, but also placing views on sheets, that's not IP right now. And your video has, there we go. Okay, so with that, I'm seeing some questions come in. Feel free to answer anything I may have started there with a question or not.
Oh, okay. How's the audio? I think I've got a question from Kiran Gola.
Yeah, let's go for it.
Hopefully I'm saying that okay. The team composition. So I'm part of the digital design group. We've got a few BIM managers who look after sort of BIM within the team. We've got a few people who are experts in applications generally. So we use a lot of Revit, SketchUp, MicroStation, Rhino. And then we have a full visualization team using some pretty incredible technology. We use Unreal. And we need people who are sort of experts in all the applications and sort of can help fight fire on a day-to-day basis. That's very important for us because we're very large and we have a lot of Revit projects, probably 50 or so being worked on live on any particular day. So we've got someone who's head of digital design who kind of deals with sort of strategies, negotiates sort of licenses, these kind of things, help kind of lead our direction in terms of technology. There's someone who kind of is a go-between between sort of the architectural side and the visualization team. So we have a full visualization team, and there's someone who kind of understands sort of a bit of both worlds. A guy who's expert in sort of surveying and point cloud. We've got.
But when you're looking at the specific Homegrown, and you look at how it kind of came about, what was the team for that, and who helped drive kind of the conversations and the management side of that?
Sure. Okay. So the head of digital design, my manager, I think was very good for sort of bouncing ideas off and sort of understanding how to sort of make it work within the context of the organization. I was then able to, from chats sort of with him, then I was able to sort of get the sign off on the time from the business. I put together a full kind of proposal, PDF, timelines, how much it's going to cost, how long it's going to take, and break everything down. And then I did a massive initial sort of scoping exercise with sort of architects working on residential teams, and also sort of more like higher level associates working and sort of leading those kind of projects. So, they might be leading 5, 10 residential projects across the practice. And then you want to talk to people who are kind of more on the ground. So you want to get a sort of a strategic understanding of kind of why this tool might be useful, like what kind of stage in the life cycle it could be useful, what kind of data is important, how they work, and then you wanted to get an understanding kind of from the people on the ground of, what are the parts that I could potentially automate that would be incredibly helpful. Something else that was important was when I was devising this kind of list of features that mattered a lot when comparing apartments, there are things I had to take into account. What is available via the Revit API, obviously. Those are my hard limitations. There's what matters to architects. And then there was a third category of sort of what do I think I can reliably get from an architectural model, basically requiring nothing of the user. So I design applied tools for my job every day. And it's kind of a nightmare because you can't really rely on people. You've got to do things in this format. You've got to do things in this way. Oh, you have to set up these parameters. You can't have any of that. So the thing with Homegrown is it's designed to automate all of that and rely upon the things it knows it can rely upon, which is a floor plate and some external walls bounding a space. That is it. So, for instance, one feature that would be very
it's also a starting point, right? It's not like a finished. I mean, you might consider it a product because even things like Netflix and Windows are constantly in development. But I think if I remember from when we were talking about it, it doesn't. The objects may not even land next to a wall when you're finished with the current version. Like that's growing and improving. But it's useful as it is.
That broke up a little bit. Sorry.
Oh, I was just talking about how finished is it? Is it like, oh, I clicked the button, I ran it, and now we're sending documents out, or is it helping at the ideation stage and then kind of transitioning to something else? Where's the current status of that? Like the real side of it.
The intention was always to do about 90% of the work for 90% of the apartments. And it's pretty solidly tested. I'm quite happy with it. We've gone through a lot of internal rounds of testing, sort of with various architectural teams, sort of having people who are interested in it sort of play with it. The idea of what it can do, it can be expanded a lot further. So, it gives us effectively complete control over sort of data and content in terms of Revit families and data in terms of parameter values, naming, that kind of thing. But that itself allows us to unlock a lot more. So we're able to, each bedroom can know it's a bedroom. Each bed can know that it's a bed in a bedroom and how many bed spaces it's got. Everything can kind of be standardized in terms of data. And then we can rely upon a lot more because we've got this library that we can increasingly expand in terms of the number of apartments, but also the depth of the data that we go into. So one of the things that I thought could be an interesting USP is that we have all these expertise, people experts in fire, health, safety, specification, etc., BIM, within my company. And we could sort of embed their knowledge for an early stage residential design, not construction level knowledge, but early level, we would say Reba stage 1 or 2. You could embed that kind of data in and then just proliferate it effectively. You can even apply logic to it. So it's to answer your question, it's kind of a decent working product that gets 90% of the work done for 90% of projects. But actually, in terms of how it can be expanded, this really is sort of just a first step in what it could do. I think it could do things like checking minimum dimensions, compliance, flagging for issues up in design, that kind of stuff.
Yeah. We have a question here about how you got into this and what you learned. The question is specifically around machine learning, but I kind of want to expand it. Like, how did you get into statistics? How did you get to where you're at in the journey right now? You said you started as an architect. Oh, did we lose him?
I'm here.
You're back.
I can hear you.
Back. I saw you.
I can hear you. I've always kind of been quite into my tech. So I used to have a video games company with my brother before going to. We used to build video games in Flash, if you remember that, and we put out about 20 of those and sold them. I did dissertations on things like cloud computing, on sort of building parts of the internet, but space programming. I only got started about 4 years ago, just before I joined. So it's been quite a rapid time. In terms of the machine learning, so I just kind of jumped straight in. I did a course with the Emeritus Institute of Management, which is run from Columbia University, and I did an online distance learning course for 12 weeks, 10 hours a week, And so I begged my company, can you please pay for this and give me the time? And I pitched it to them and said, look, there's going to be all sorts of benefits, we think. And I think it was at a time when there was an insane amount of machine learning hype. This was in the summer of 2019. Machine learning, AI, everything, deep mind, it was all kind of going. So I did this course, and it kind of forced me to learn a lot of linear algebra, a lot of statistics, and a lot of calculus very quickly. So I can tell you how I did it. Firstly, Google is your friend, and you can learn nearly anything you want by Googling it. But
What an era.
specific shout outs to if you want to learn linear algebra on YouTube, 3 blue, 1 brown. That's like the best channel for mathematics ever. And if you want to learn statistics, StatQuest on YouTube is really fun. So it's run by this kooky guy who plays ukulele and he makes up stupid songs. And they're just super, super fun ways to learn what can be quite a dry subject with the statistics. He makes them really fun. Those were my 2 best places to learn. And I have to say, even though I did learn from this course and it did cost money, I found it much easier sometimes to absorb the content, not from this mathematics professor, but from StatQuest on YouTube. That is a very, very good machine learning channel.
Yeah. Well, you're getting a lot of love from the chat. I know you're seeing it there, so definitely make sure and look at that. And with that, I think we're gonna cut this off, guys. Thank you, Oliver, for your time and energy you put forth towards this. Thanks for being available at 9:45 now at night, instead of joining the rest of London and Netflix hour. And we will, like I said, we will re-record this at some point. I can't make any promises since we are a pretty small group. I'm actually going to be moving. We're going to have a new background probably sometime in the next week. Fingers crossed, anything can happen. As we all know, there's tons of unforeseen conditions that can happen. But with that, thank you for being with us. Sorry about the audio glitches we've had today, but we will try to get you something. I do think live is still the best way to do this, even if every now and then we have these kinds of bumps. So with that, we will